All right, so I'm going to skip the game theory stuff today. So we'll talk about, start talking about competitive balance. I don't know if I'll get to it this afternoon. I might kind of be, why is this not? There you go. I might be grading for another class I have, but I might get started at least on grading some of those homeworks and then reading through those proposals. So over the week, you see things kind of pop up on Canvas. I'll probably leave it some kind of a comment on your proposal about either maybe I might have a clarifying question, or here's some data I know like this. Does this sound, maybe redefine your question just a little bit. And so kind of keep an eye on Canvas for those comments. And then the way I typically grade the homeworks is I put any points that I take off, I'll put in the comments section there. So as I'm kind of grading those, you'll be able to see, okay, where exactly did I miss any points? And if you have any questions on that, please feel free to reach out. Okay. But that, I'm not going to get it all done today. That'll be happening throughout this week. I'll be doing both of those. Okay. Any questions for me before we jump into things like today? So a little bit of this we kind of already talked about. We'll just kind of revisit it. But if we think about competitive balance, another kind of term we said we have for it is like parity, right? How similar are the win percentages across the teams in that league, right? So what stats can we use? We kind of already talked about variance and standard deviation are a good one. We could also just look at the range of wins, right? The highest possible number, or the highest number of wins to the lowest number of win teams. And we could look at this like over time. We could compare across leagues. Several types of various or comparisons we can take. So usually we'll use win losses. That was the kind of example I introduced last class, was using this win percentage, calculating that standard deviation. We also talked about, well, we have to make sure we then convert that to a ratio, because the number of games will kind of influence what that ideal standard deviation win percentage is. So other things we can do is not just think about, okay, maybe we have for 10 years in a row, very low or low ratio, right, or low standard deviation relative to the ideal, right? But if we have the same team winning every single championship in that 10-year period, well, that's also kind of a measure that we don't have a very competitively balanced league, right? It doesn't matter if the rest of the league is competitive, but we have one just ultra high quality team that's winning every single year. Well, then you can think about it this way: if I go into a season, uncertainty in outcomes matters, right, in games. Well, if I go into the season, I'm like, yeah, there's no way those Goldens, go back, I don't know how many years now, like there's no way the Golden State Warriors don't win the championship this year because they've got such a high quality team. Well, then why am I even going to watch any of the games in that league, right? So having kind of turnover at the top is actually a good thing as well. We want to make sure we have competitive balance and not just wins, but who's winning the championship, right? Same kind of idea. We could do division leaders or conference leaders. We want to make sure we've got some turnover, right? So why should these teams care? We kind of already talked about, right? We know, we've looked at a paper before, that outcome uncertainty is good, right? That if you've got kind of this demand curve and it's any means influenced by outcome uncertainty, we want to make sure that we've got some parity, right? That people aren't sure, or the outcome of the game isn't guaranteed going into it. That increase in higher demand, right, kind of lead to higher profits, right? So we already looked at this paper, actually. It was one of the weekly readings that we did, kind of finding that we have less parity, right, or more certain outcomes, right, that teams are kind of further, the gap in quality is larger, that we actually see we actually see like reduced, I think this was attendance, if I remember right, at those games. So it's difficult to maybe get an idea about or improve parity if we've got different behaviors like win versus profit maximization. We'll talk a little bit about this with revenue sharing. I'll revisit it here in a second later on today. And why, if we're win versus profit maximizing, might it be harder for leagues to kind of decrease, right? That not decrease. We'd want to increase the outcome uncertainty, right? Or kind of increase parity. Okay. So we'll look at an example of this. So it's kind of a nice, kind of wraps up why this matters. Okay. So if you go back a long time ago, 1950, and you look at what's, I think it's a nine-year time period, or 8-year time period, the New York Yankees won 6 of those 8 championships. Right? So attendance in the American League and in the Yankees games over this time, although they were a high quality team, they won 6 out of the 8 championships, their attendance was actually decreasing. Right? So there's this kind of nice little table. They went back, found some old data, or got some old data from the Yankee organization that you can kind of see, like, over this time period, who won in the American League. The Yankees won every year except for 1 year, right? Now in the National League, or sorry, in the World Series, we had a little bit more turnover, right? Yeah, the Yankees won 6 of the 8, but the other teams that won from the National League were all different, right? And so we had a little bit more parity in the National League, not as much in the American League, right? So if we look at the attendance, what we should expect is that American League attendance was declining during this period. But the best teams in the National League were always changing, right? We had a little bit more kind of parity. So first thing that's interesting is that, well, all the games I know the Yankees are going to win, fewer and fewer people start going to the games. It kind of got stable, or kind of stabilized here, but still kind of decreasing over this entire time period. We look at the American League attendance, same kind of thing. You kind of see it really dipping down in some years, kind of spike back up in a few, but for the most part, kind of we saw this decrease in attendance. Right? Now, this could be overshadowed, like, so we start to see this initial decrease and then it spikes back up again. Well, maybe there was just an increase in demand for baseball overall, right? There was other things happening in the demand curve for baseball that could have driven this attendance up while that parity was still having a negative effect. We can kind of get a good idea about that if we look over at the National League. We look at the National League, well, they actually, they saw a dip too, but then they saw an increase, right? In the years where some of the National League teams started winning, well, now there actually is the possibility that our conference's winner, or our, I guess conference, but our league's winner can actually win the entire thing, right? And so here, once we get to 58, they actually have the highest attendance they ever had. While the American League has one of the, I think, second lowest that they had over that time period. So just kind of a nice little quick snapshot of how outcome uncertainty matters, right? Why we want to make sure we have a competitively balanced league. Okay. So we've already talked about this as well, like teams market size, large versus small markets. We can use city populations. We might want to think about, with broadcasting, maybe it's not just our metro, maybe it even matters the state that we're in, right? Because if we have local broadcasts, like, maybe it's that everyone in the state is going to be, more likely to become a fan. So it's kind of hard to measure, but we do know there's this difference, right? So what gets kind of interesting is, okay, we want to make sure there's competitive balance, right? That the gap in wins from the highest to the lowest team is not that wide, right? The problem is, what do I know is true about the wins that are the revenue from wins that's generated in a large market versus the revenue from wins generated in a small market? Every win in that large market is going to generate a higher marginal revenue, right? That was the idea. We have this higher demand and higher marginal revenue curve. So for the league to maximize profits, they have this real delicate balance of, okay, we want to make sure that one of these things that's impacting the demand curve for every game, which is competitive balance, we want to make sure that remains relatively high. If you think about, a real balanced league. However, if we get a more balanced league and the large market teams are winning fewer games, small market teams winning more of those games, or gaining a lot less by those small market teams winning than what we're losing out on from those large market teams, right? So it's this delicate balance of, okay, what is kind of the relative size of the amount of revenue lost from having an unbalanced league? And we're okay if it's a little bit unbalanced if our large markets are the ones at the top, right? Because any revenue lost from not having a balanced league will make up for it in the fact that those large markets winning more always going to translate to a higher number of dollars, right? Or a higher revenue. Okay? So we kind of want to make sure that if we do have this, disparity, or we do have a league that's not really competitively balanced, that at least the teams at the top are our large markets, right? If that's not the case, then we're really concerned, because now our small market teams aren't generating near as much money from wins, and we're losing a lot of money from the fact that we don't have a balanced league, right? So it's always kind of this trade-off, right? So we would want some disparity, right? As long as it's those large market teams at the top. So we talked about this last class, so I think I put those in here because it's all on the same kind of discussion, but we went through kind of creating these ratios last class. Okay? And then we talked about, so this is where we left off. Okay. So another thing when you think about impacting competitive balance that could vary across some of these leagues is a little bit dependent on the sport itself. So when we have diminishing returns at the same position, right? So we're looking within the same position. If I, want to go out and get to the best kind of player at that position, he'll have the highest kind of marginal, wins, add the highest number of wins to my team. And then I get the next best person, they would have another number of marginal wins that they would add to my team. The problem is, it's not like, it goes back to the idea, if I'm, in the NFL, I go out and I get Patrick Mahomes. If I think he's the best quarterback, I sign it, right? Well, yeah, the decline in the marginal number of wins might be really small. If I was instead to have added Patrick Mahomes, I instead added, Jalen Hurts. We'll just use the 2 Super Bowl, right? Well, yeah, that might be a small drop, but if I have both of them on the same team, well, what's the number of additional wins that Jalen Hurts adds if I've already got Patrick Mahomes as my starter? Not a whole lot, right? There's a real sharp decline. But that first quarterback I add, yeah, I want to make sure they're the best. But as I add more quarterbacks to my team, their marginal number of wins they add dramatically drops, right? You can imagine in other sports where this might not occur. So I think I've got some old examples, right? If you get, this was back when Cam Newton was actually, I thought it'd be good. But right, you might have these high costs to adding kind of this quarterback who maybe the quality of play isn't that high, right? And they're really not adding that many marginal wins because you've already got a starting quarterback. Okay. And it becomes costly, right? Even if you think about this as well, yeah, they may not add that many wins when they're playing the field, but if I'm taking them away from another team, that's going to help me out as well, right? That's going to add a certain number of wins. Well, the problem is, yes, that's true, but that's a very high cost to do that, right? If I'm going out and getting the second best quarterback after I already have the first best, well, it's very costly just to stockpile to prevent other people from hiring that player. So if we have this sharp decline in marginal wins or marginal production from these players, it's going to help us avoid getting a league that's out of balance, right? Having poor competitive balance. Because if there's sharp diminishing returns at a position, well, it's way too costly for me to keep this second best quarterback from going to another team, right? Because they're not going to really bring in a whole lot of additional revenue to me, so it's just me paying this higher cost. What's interesting though, if we had positions, so this is the idea of quarterbacks. If we have a sharp diminishing marginal number of wins or marginal productivity, then yeah, it's going to help us have a more balanced league. But what if I've got a position where there's not a sharp decline? So a good example I can think of this is if we go over to like Major League Baseball, right? Pitchers only pitch every 5 games at best, right? So if I get that first best pitcher and then I get the second best pitcher, well, it doesn't matter. They're going to both now add a really high number of marginal wins to my team. They're both going to be very productive because one of them playing doesn't prevent the other from playing just as many games as they would have before, unlike kind of the position of quarterback, right? So anytime we have a situation where it's not declining as quickly, well, then it actually presents challenges for the league because if that's the case, I can stockpile. If I'm the Yankees and I want to, I've got all the money, I could go get the 5 best pitchers. And it's not going to be, I'm not just having them sit the bench. It's not going to cost me like, yeah, their salaries will be high, but I'm also going to get a lot of production out of all 5 of them, right? So this idea that we have kind of a more, not as steep of a decline in marginal production might actually hurt those leagues in terms of competitive balance, because then your large markets can stockpile at that position. Now, there's not a ton of that's kind of a unique one with pitchers where you really can, it's not like anyone's sitting the bench or taking time away from anybody else, but it does exist, right? It's an extreme, but it's an extreme that does exist, right? So any league where we see a sharp decline in kind of within position in marginal production, they're going to have a more balanced league than if we have positions where we don't see as sharp of a decline. Trying to think of another good example of this. Probably outside of like the main professional sports, if you think about something like, I don't think there's a lot of money in this, but this is just a hypothetical to kind of think about this concept. So let's say you had professional runners in track, right? I'm sure there's a league that exists. I know the Olympics is like the biggest thing. I know there's like a annual championship as well, right? if I wanted to build my relay team and I can go out and maybe spend money to attract people to be on my relay team, well, I can get the 4 best runners, right? And I'm not, none of them are kind of sitting on the sidelines, taking time away from the other, right? They're all very, very valuable in adding kind of additional wins throughout, whatever the season is with all the different track championships. So there are examples where we don't see this sharp decline within position. I just kind of think of the pitchers one as kind of probably the most obvious, right? But there definitely are others that exist. Okay. So I kind of already mentioned that we can look within season last class, like we're doing standard deviation win percentages, but I might want to look kind of between seasons, right? Or kind of across seasons as well. So within season was a little bit easier, right? We're probably looking at win percentages. Or the number of wins, if we want to look at it that way. It's really our primary kind of measure, right? But it's not quite as clear if we want to look across time. Well, I guess I could look at, all right, what was the standard deviation in win percentages each season? And then, okay, what was the standard deviation in those standard deviations across, the last 10 years, right? But that gets kind of a little bit weird to think about. Something that's probably a little bit more likely if we're looking across seasons or between seasons is we look at a turnover at the top or turnover in the number of playoff teams, right? So one way we can do this is use something that you've probably already seen, even like in the principles of ECON, which is used as Herfindahl-Hirschman index, right? It gets a little bit different, right? Usually we're looking at like, what's the percent of total sales from this company out of the sales in that industry? Well, now we're looking, okay, what was the number of years that we're looking at? What were the number of championships possible? And how many times did that first team I'm looking at win the championship? And then adds that, how many times did the second team win a championship in that 10-year time period? How many times did the third team? I do that for every single team, squaring those ratios, and then add them all up, right? So every single time I have a team that wins a championship, right, this is going to have a positive value, squaring it, right? I'm going to add a positive value to this HHI or this Herfindahl-Hirschman index. Every time where I have a team that has no championships in that time period, well, it's going to add a 0 there, right? So as that HHI gets larger, I'm getting higher positive amounts added to it. That means that more of the championships are concentrated with the same teams. Okay? So a higher HHI tells me that the league is actually more imbalanced. So I'll show you some data here in a second. We'll actually kind of construct this for 2 different leagues. Any questions on this before we do that, though? Maybe in practice, seeing this with some actual data might help and make a little bit more sense. So let's go to, I put this up under the Files tab on Canvas. So I think this one was NBA Champions. And I actually have 2 worksheets. Oh, I only opened up one of the data files. There we go. So there's actually 2 worksheets on here. If I can get the stove. There we go. So there's one for the NBA, one for the NFL. So we can actually look at the kind of competitive balance, not just within season, but across seasons and compare it to these, between these 2 leagues. So the data kind of comes in sloppy. It's got who the championship was that year, who the runner-up was, and some other data, right? Well, really all we're interested in is, okay, what were the teams that won, right? So I'm just going to kind of look at what were the champions, right? So I'm going to actually just select my entire data. We talked about this last class, and I'm going to add a filter to it, right? This might be an easy way to do it. I'm then going to sort my teams, right? So I very quickly can see, okay, here's the teams that won a championship. So I've got one team that won 1 championship, right? I've got a second team, and actually, if I wanted to, I'll show you how to do something else in Excel that might make it a little bit easier. We'll just insert a column so we can kind of write next to them. So this team won 1 championship. How many did the Warriors win? 4. Lakers won 1, Heat won 2, and the rest of these teams all won 1. Right? So I'm then going to right click again, insert another column. So just going to label these. I'll save this and kind of re-upload this so we can see the work when I'm done. And now I'm going to get kind of my amount that each one of these teams is going to add to that HHI. So remember that HHI kind of looked at the number of championships out of the number of years squared. And we kind of think about it here. We start with the first team, and we know that we got what, 30 teams in the league. Right? Now, it usually doesn't matter because once we start getting to teams that aren't up here, what's this value going to be if they add to the HHI? The team hasn't won a championship. 0 over anything is 0. 0 squared, they add nothing to the HHI, right? Remember? So let's go. We could say, okay, take that number of championships that team won, divide it by what? We're looking at 10 years, or no, 11 years here, right? Got an 11-year time period. And then I'm going to square that value. I just realized I'm seeing people squint because I sometimes forget to blow this up so you can see what I'm doing. All right. So all we're going to do is go through each one of these teams and figure out how much were they adding to that HHI. Now, if I just copy this down, it's going to update right here. Now, these zeros I don't really need, right? Because I was kind of grouping this by the team, right? So I could get rid of those zeros. Those were kind of teams that won multiple championships. But now I've got all of the teams that would add something to my HHI. Okay. Well, what's the last step? I just need to add, oops, move this out of the way. I just need to add up all those values, okay? And we get about 0.2. Now, in practice, I'm not going to like try to trick you with this, but generally, we see the HHI then multiplied by 10,000, or you can think about it as you're just multiplying that win share to get it as a percentage form. It doesn't really matter in the sense that as long as you're calculating it the same way, you can compare across leagues, right? So we know here, what would the highest HHI, if I don't multiply it by 100 and kind of have this percentage format, what's the highest HHI I could ever see? So it's trying to measure the concentration of championships that are won by teams. One, right? What would that look like? Of all 11 years, the same team won all 11 championships. So the highest HHI we could ever see is 1 here, not, just calculating in decimal form. The lowest we could see, we could figure out if I've got 11 years, what would the lowest possible be I could see there? Not necessarily a specific number, but what would it look like? 1 over 11 squared, and then there would be 11 of those, right? So you could figure out what that lower threshold was depending on how many years you're looking at. And the way you would do that is, well, then as balanced as you can ever get is that you have one, a new team every single year, right? So every team in that time period only has 1 championship or 0, right? 1 or 0, if we look at it that way. Is that making sense? Any questions on that? So hopefully you can kind of see, we want to start being able to kind of play around with some data a little bit. If I was doing a project where I had something I was interested in competitive balance of a league, I could very quickly kind of look, okay, what's the turnover at the top? And this gives me a quick snapshot. Now, obviously, for like your project, probably more than 11 years, and we could go further, but also show you how we could do this in the NFL as well. So for the NFL, I think what I'm going to do is something that's a little bit, well, do we have any repeats? Yeah, we got enough. So we'll just use these guys, the winners of the Super Bowl, right? So we'll go to data. We will throw a filter on there. I'm going to insert another column. I'm going to sort these. I'm going to blow this up so we can all see what I'm doing. Okay. So I've now got every single team that's won a Super Bowl over this same, actually, this one's only a 10-year time period. Okay. So I'm going to look at how much do they add to the HHI. I'm just going to, or actually, no, sorry. The first thing I need to do, trying to keep the same format as I did on the other one, is the number of championships, right? Then I'm going to insert another column here. I can stop making this bounce all over the place. This is kind of how much they're going to add to that HHI. Well, here I've got the Ravens won 1, Broncos won 1, Chiefs won 1, Rams won 1, Patriots won 3, 1, 1, and 1. So hopefully before we even calculate this, we can kind of see like it's a little bit more balanced of a league in terms of turnover we have at the top, right? Between season kind of competitive balance. From there, it's just a matter of take the number of championships that team won, divided by how many years I'm looking at, and I forgot a parenthesis here, and then square that value. Okay. Once I have that, I could copy this down. I don't really have to delete my zeros because when I add these up, 0 doesn't change what I'm going to get. So I could then just add this up. And I say, okay, yeah, the HHI in the NFL is actually lower than that in the NBA. And it kind of makes sense if we just look at this here. You know, we had 2 teams that won multiple championships, but one of them won 4. In the NFL, over a similar time frame, we had only 1 team winning multiple, and their highest, I look that they won this is a 4-3. So we'd expect a lower HHI, and sure enough, we get a lower one. Right? Now you can do this over like much longer time periods, right? Which it's just a little bit more work. You could do NHL, you could compare whatever leagues you're interested in. And you could also do this in like, different conferences in college football. Right? You look at like what the turnover of the champion is at the top or something like that. Any questions over anything I just did there in Excel? I know I'm going through it kind of quick. I know that not everyone has the same level of Excel. So the lower the HHI, more the lower the HHI I shouldn't say the better for the league, because we had those other like concerns of like we want our large market teams to maybe be better. But yeah, if we're solely focused on competitive balance, we want as low of an HHI as we can possibly get. Now it can't be 0 because somebody has to win the championship, but we can get it, drive it down closer to 0. And then the closer it gets to 1 means the more unbalanced we have, right? 1, the same team won every single championship in that time period. Questions? So I don't know. I hopefully I'm going to kind of go back and forth today and show you how we do calculate and do some of this stuff in Excel. Like I said, if I'm ever doing something and you're not sure how I did it and I didn't say it, I'm assuming you have some level of knowledge in Excel. I had a lot of you in 221, so I know you at least have that experience. But if you ever have a question over anything, make sure you stop me. Okay. All right. So we talked about between season variation. Oops. Go ahead here. So another thing that we could do, this is a little bit more like within season variation, comparing to something you've already heard about or probably seen in the principles, is the Lorenz curve. Now, usually we use a Lorenz curve to look at income inequality, right? Here, instead of income inequality, what we're going to do is think about win inequality, right? So you can break this down. Typically, we'll do this into quintiles. So the bottom 20%, the bottom 40%, the bottom 60%, bottom 80, and then bottom 100. They're all. Okay? We're then going to look, okay, the bottom 20% of teams, the teams that have the lowest number of wins, what percent of all the wins in the league do they have? And then the bottom 40% of teams, what percent of wins did they have of the entire number of wins in the league? We're going to do this for every quintile and then just graph those out. Right? So I'll show you how we do this in Excel. Might make a little more sense here in a second. But you can think about things like if the bottom 20% won only 13% of league games and the bottom 80% maybe won 63. Right? An ideal Lorenz curve, it would be, and I say ideal, perfect balance, right? From our Lorenz curve would look something like this. Right? So percent of teams, percent of wins, right? We would do, okay, the bottom 20% of teams, right? The kind of lowest 20% in terms of wins. Maybe they've got, if we had a perfect world, they would have 20% of the wins, right? If they had, with the bottom 40%, they would have 40% of all the wins. So an ideal Lorenz curve, I guess it stops here. And I won't kind of graph every single point between, but you can kind of imagine every team is winning the exact same number of games. So no matter what kind of like quintile I look at, every single quintile is winning the same percent of overall games, right? Bottom 20% is winning 20% of the games. The bottom 40% winning 40% of the games. Bottom 60, so on and so forth, right? So this kind of ideal competitive balance Lorenz curve would just be this 45-degree line, right? Does that make sense why that would be that way? Right, this would be like if every team had the exact same number of wins. And then kind of going from that point, we could calculate things like a Gini coefficient. I'm not going to handle on this too much, but just related to something I've already heard. We could take like the area under the ideal curve and then do a ratio of that to where is our actual curve, because we look at the data, not every team has the exact same number of wins, right? And we can do things like calculate Gini coefficients for these different leagues as well, right? So I'll show you how we do this in Excel. I have a slide here, but let's go instead. I put some NBA wins data up there as well. So formatting is a little, I should have changed it, but it's fine. It's got the data we need. So that's all we really care about. I guess if we were really concerned about, here we could do copy. So how did I do that? I should say. So a shortcut, if you forgot in Excel, if I hold shift and I use my arrows, I start to select like multiple rows or columns. If I hold control and shift and I use my arrows, it goes all the way over to where the very last, or the last cell that has something in it, right? Well, here I'm going to hold shift, just go over one. I'll select my first two columns. Then I'm going to hold control and shift, hit the down arrow. I'm just going to copy these team names and the number of wins. So if you ever have some weird formatting stuff like that, and like I said, I should be able to help most of you get the data that you need for your project. But if you're ever going out and getting some on your own, if a lot of the times, well, I put the reference in here for a reason. So I'm going to pull this up to kind of show you where I was grabbing this data from. So there's not like great repositories for all this data. This is going to be a great resource. This is where if you come to me and you have a project about one of the 4 leagues, a lot of the data is going to come from here. Problem is, it's not like easily searchable and downloadable. It's just like presented nice, right? Now, if I was, you had a little bit more, there are packages that like in R and Python that will scrape this, and that's often what I use to do it quicker. But I'm not going to expect you guys to know how to do that. But what you can do sometimes, if it's just a small data set you eat, instead of messing around with Python, you go down here. Okay, I've got these tables. It's giving me the number of wins for every team in the NBA that year. If I get here where I select this, I can just copy, go to Excel. I'll go on a different sheet so I can show you. Maybe not. There we go. Then when I go to paste, there's 2 options. If I am lazy and I wasn't paying attention to what I was doing, and I do the match style, I get some of the goofy like shading and different things that was on the website. If I just want the data, if I go to match destination, it'll always just kind of put that as kind of some nice, clean, same font, same color, same everything. But just kind of a practical thing I think is worth kind of showing you a little bit of like, sometimes data is out there, but you can't download an Excel file. Okay. If it's like in an HTML and like it's in a table, you usually can just copy and paste that into Excel, and now you've got that data where you can actually use it. Okay. So we'll go back. Where's the other one? Here we go. So I'm going to select all these teams. I'm going to put a filter on here. And I'm going to sort from largest to smallest. Okay. So this is where it takes a little bit of time. There's probably some fancier ways you could do this in Excel, but without kind of going into depth into like different functions, I'll show you an easy way you could build these Lorenz curves, right? So if I've got 30 teams, right, and I want to break that up into 5, like quintiles. So I've got 5 quintiles, like 20, 40, 60, 80, 100%. How many teams would be in the bottom quintile? Well, 20% of teams, 20% of 30 is 6. Right? So I'm going to break this up in like the lowest 6, then the next lowest 6, the next lowest, until I get to the highest, right? So I'm going to go down here. 1, 2, 3, 4, 5. Here's 6, right? The 6 lowest teams. Right? I'm going to calculate what their total number of wins was, right? And once again, I am sorry, unless I put this on ahead of time, I always forget to do it, right? So all I did there was add up the number of wins from that lowest 6 teams. To figure out what percent of wins those teams had, what do I need to divide that by?
Total number of games in the league.
Total number of games, or how can I find that from this data? Well, I could just add up the wins that every single team had, because as long as I have something where there's a winner and a loser, maybe why I chose the NBA here, I can do this. Now, if I have ties, that's fine. I might, I would have maybe changed the definition that like I'm looking at the number of wins out of still the total number of games played. It becomes a little more challenging because then I have to add up the number of wins and the number of ties, right, to get the total number of games. But if I just have a win-loss kind of league, well, I can just add up the number of wins, and that will be the total number of games. But you're right. If I had ties, I'd have to do a little more work there. So I want to divide this by the sum of all the games. So one thing I can do is kind of use that shortcut. I hold Control and Shift, hit the up arrow. Well, I don't want to select that very top one. So now I just only hold Shift and I go down one. I've selected every single thing. So using that Control Shift, like that's a really easy way to navigate my data a little bit quicker, as opposed to like dragging my mouse up and down, especially if I have larger data sets. So if I hit Enter, it'll take me out of the cell. Oh, what did I do wrong? I don't know. I'll also do this just in case I make another mistake and don't blow your ears up. So we get that the bottom 20% of teams, right, had what? This is always going to, if I calculate it this way, it's giving me the proportion, right? Which is fine. If I wanted to translate it in percentages, I could. I just multiply it by 100, right? So I'll go back in, maybe just to make it easier to kind of visually see in the way that we generally talk about things. I'll take that proportion of wins the bottom 20% had, and I'll multiply 100 so that I also have it in terms of the percentage. Okay. Any questions up to this point? Like I said, anytime I do something like this too, I'm trying to upload these onto Canvas so you can work along if you want to kind of bring your laptop. We don't do this every class, but so then I would go, okay, then I'm going to look at the next 6 teams. So 1, 2, 3, 4, 5, 6, all right? I'm going to say, okay, well, I'll set up the same way. 100 times, add up, okay. How many wins did those teams have? Divided by the sum of, and once again, Control Shift, hit the up arrow, only hold Shift, hit the down arrow, I'll select the entire number of wins there. I don't know what it doesn't like there. We can ignore it because I know this is correct. So Excel is great, but sometimes it has a lot of these new features where it tries to anticipate what you want to do and then tell you that you're doing it wrong, even though it's like, no, I actually do want to do this. But like if you ever get little green flags that pop up in the corner, it usually is because like what Excel generally sees people do, you're doing something slightly different. Doesn't mean it's wrong, but it's just trying to let you know maybe you did something wrong. So I've got the bottom 40% are only winning 28% of the overall games. So I then go to the next 6, and I'll do this real quick. And like I said, I'll post these on Canvas so you can kind of see the completed version. I'm just going to go through this quick so we can actually get the data. Forgot to multiply this one by 100, so we'll do that. Go to the next 6. And then once we have these values, I'll show you how they're a little more useful. Oops. Multiply this one by 100. Now, once I get, oh, did I miss one? 2, 4, 5, 6. I'm off on one of these. This is the one I'm off on, isn't it? I counted 5, not 6 teams there. So this is going to be 14. And then we'll go up here. Now it should be this one up 1. So this will be starting at B8. 2, 3, 4, 5, 6. Now we've got this one, right? So before I even do this, once I get to the bottom 100% of teams, what percent of overall wins should they have? 100. Yeah, it has to be 100%, right? So I could do it for this one as well, but I already know it's going to be 100%. Right? What I could then do is set up a little kind of table over here where I say, okay, percent of teams and percent of wins, right? This is going to be my X
and my Y variable. Okay. So this is my X and my Y variable. So the X variable, I know I'm looking at quintiles. So 20, 40, 60, 80, and 100% of the teams. I'm then going to just go through and say, okay, I'm going to use cell references. I'm not even going to type the numbers out. I know that the bottom 20%, the percent of wins they had, I calculated down here. Right? Hit enter. Okay. Bottom 40%, I had right here. Hit enter. Bottom 60, bottom 80. I got to scroll up to show you. Oh, wait. I skipped one, didn't I? Yep, I didn't go down far enough. There we go. Bottom 40. Now the bottom 60. Now the bottom 80. Now the bottom 100. Okay. So I've now got these coordinates. I can basically just insert a graph, insert a line graph, and get my Lorenz curve. So select this, insert, go over to my line graph, right? Now, when I try to do this, I get kind of this thing where, oh, okay, it's trying to graph multiple lines, right? Well, it's kind of a problem in that I really only want this line on there. So what I could do is highlight these, only insert my line graph there, and then go in, whoops, click on my numbers, right click, then go to select data. I want to change my axis labels to then be, oh, I probably have them covered now. So sorry. Doing this kind of on the fly today. So go back in. I have my mouse here for a reason. Select data, edit those axis labels, and then select those. Hit OK. Now I've kind of got my Lorenz curve where my x-axis is the percent of teams, my y-axis value is the percent of wins those teams had. Now I've got kind of something goofy here, which is I left off an important point, which is what? This always starts at 0, 0. So I go back in, add 0, 0, I can get my Lorenz curve. Okay. So this is kind of how you would use the data to come up with these things that maybe you've seen before. I just wanted to more so kind of show you like you can play around with these things in Excel, and a lot of these statistics that, or a lot of these measures that we're talking about, it just takes a little bit of time to come up with them in the data. Okay. Even if you can't find like a place to like download, you know, the Lorenz curve points, you can kind of recreate those for yourself. Okay. All right. So there was one thing I wanted to make sure we did today, which is revisit revenue sharing. So we've already talked a little bit about revenue sharing. So I'll kind of skip all this, right? We've talked through some models, but I wanted to remind us of this, and then we'll dive deeper into it on Wednesday. Well, where we'll think about not only revenue sharing, but things like salary caps, salary minimums, salary maximums. So one thing that I wanted to make a point of on that first homework, and I'm hoping that people kind of grab it. I haven't graded it, so I'm not 100% sure. If I'm thinking about, let's say I've got, oh, sorry, not quantity. Thinking about other econ classes here. So I've got the number of wins on my x-axis. I've got the marginal cost to win, keeping it constant. Okay. If I then had, you can choose the colors. So let's say, here's my marginal revenue for my small market team. Here's my marginal revenue for my large market team. Right? One thing that we know is going to occur, and I'm not going to draw the demand curves up there just for simplicity. We're going to assume both of these teams are profit maximizing. So we know that it doesn't matter what the demand curve is in the sense of we're going to identify the small market and large market teams' number of wins just based off of where marginal revenue hits marginal cost. Right? So we want to remember, let's say we do revenue sharing where we take 50% of, doesn't matter, ticket revenue from these teams. Well, I know these marginal revenue curves would then decrease, right? Because I keep not the whole dollar now that I earn, I keep 50% of it. But what do I know is going to be true about the relative size of those shifts? So let's say this, for the sake of having some numbers, I don't know, think about maybe this is the NFL. So we've got, these teams are targeting 5 and 10 wins. What's going to be true about the shift for the small market relative to the large?
Well, they had a lower amount of revenue before, so 50% of say $100 million, right? I'd see a $50 million shift. If I take 50% of $100 million from the large market team, sorry, that was my first one I said, 50% of 100. If I take 50% of $200 million from the large market team, that's a $100 million shift. So I always know that if I'm using a percent-based revenue sharing, the large market team is going to experience a much larger shift than that small market team, right? I'm trying to draw this, right? The shift in the large market was much larger than the shift of the small market. So it might be something like, right? Now they target 2.5 games. Now they target 5 games, right? They had 50%. We're just going to assume that we had some nice linear equations. So I saw the reduction in both of these was half as many wins as before, right? However, what's happened to competitive balance? Well, before, what was the gap in the wins between the large and small market team? You can kind of think about this as like, actually, let me give you some. So this was wins for the large. This was wins for the small, right? So before, if we looked at the gap in wins, we had what? 10 minus 5 or 5, right? Now, we look at the gap in the number of wins because it disproportionately affected the large market teams, or it shifted their marginal revenue curve a little bit more. Notice we get the gap in games has actually been reduced, right? So if we use a percent-based revenue sharing program, because that shift for the large market team will be lower, we should be able to, as a league, reduce competitive balance here, right? Now, remember, it kind of gets weird. Both these teams are targeting a lower number of games. So there may also be an unintended consequence of trying to improve competitive balance. If my teams are both targeting, and this would be reflected for every team, right? Every team, if they have to pay in, they're going to see the shift. What's happened to league quality overall? Competitive balance is improved, but teams are trying to win fewer games. There's a not as great of an incentive to win more games. So I might see the overall quality of kind of play, or the amount of intention these teams are putting into winning games, actually be reduced. Now in practice, once we play the games, we're going to have the same number of wins in our league, right? But if those wins are occurring from lower quality teams that aren't investing as much into winning, then I may actually see a shift in my overall demand curve for that sport. So yeah, competitive balance, we can improve that. We can use revenue sharing, and we can, maybe make a, more balanced league. Problem is, sometimes a balanced league is going to, affect the overall quality, right? If these teams are profit maximizing, and that's going to kind of impact overall demand curves for the league as well, reducing marginal revenue, reducing profit levels for these teams. So it's great to try to improve competitive balance, but it's a delicate game because you don't want to throw in too many disincentives to not target a higher number of wins. Is this kind of understand? Any questions on this? So this is like something we talked about before, but I'm just kind of extending it a little bit, taking our revenue sharing. Now, what we'll do next class, I'll show you another revenue sharing where if we build in, okay, they're not profit maximizing, things might be different. Because if I'm win maximizing, I'm giving that money to teams, they're going to spend it, right? So we'll look at next class how win maximizing, having those average total revenue curves in there, will kind of potentially change, what we might think the impacts of revenue sharing would be. We'll talk more about competitive balance, and I'll probably show you a little bit more in Excel, probably actually running a regression, showing you how to add in that tool, because it's something that I'm going to expect from everyone's project to have some regression analysis. Okay. I also, as I said, I'll be grading kind of those first homeworks. I'll get the second homework put up. I probably won't get that done until tomorrow, but if you see that pop up on Canvas, due date will be like 2 weeks down the road, so we'll have plenty of time to kind of start working on that. But if you see that pop up there, I'm just letting you know it might be there before we start class on Wednesday. Okay. Yeah. Yeah. So I actually already put the reading up there as well. Some weeks I can't decide what I want to do. This week I knew of a paper, I had a clear-cut idea. So I always try to put the old weekly readings in wherever the folder's at. Oh, right here. And then I just kind of, whatever the current one is, I'll just throw it up under the file. Yep. But on Friday, we'll be going over that sunk cost and salary cap. Yep. All right.
Before you guys get out of here for showing up today, let's just give everybody 10 out of 10. So as you're heading out, whatever letter you're feeling like today, kind of get credit just for being here, participating, being here in attendance. Other than that, as long as you answer, kind of head out, and I'll see you guys on Wednesday.
So what is the deviation from the quintile percentage of wins? What is that deviation like mean?
Tell you?
Yeah.
Okay, so think about what we had there.
Right.
Basically, if we know that this line would represent perfect balance, the further we get from that line, the worse the competitive balance is. It doesn't have like a interpretable kind of value to us, right? Like it doesn't like yeah, there's nothing we can really interpret as. All we can say is that as it gets larger, right? Or when you say larger, as it gets further away, that gap between the ideal curve and the actual curve gets larger, and we're getting more and more out of balance, right? But yeah, it's not really a standard deviation measure as much as it's just
Right.
how far away we are from this perfect balance.
Yeah, I guess I mean, you don't want a perfect balance. If you have a bunch of teams that are all 500, how do you decide who wins?
You have all the teams that are
So like everybody, like go back to NFL
Yeah.
when there were 16 games,
Mhm.
every single team finished 500, 8-8.
Yeah.
Who goes to playoffs?
Yeah, so that'd be a problem, right? So that's an additional problem the league might see a detraction from demand because now, every single team has the same number of wins. What you could actually do in practice to complicate it too much, but from that ideal curve, you're always gonna have deviation. So even if I'm targeting, how do I explain this? If I flip a coin 10 times and I know the outcomes are 1-0, think of that as like a win or loss. Even though the expected number is 0.5, the standard deviation exists on that. And so in practice, if I flip a coin 10 times, it's very rare that I'm always going to be exactly 5 out of 10. So you basically could figure out how likely it is you end up with that scenario, that even if every team's probably winning is 0.5, there's deviation from 30 teams, whatever that standard deviation is, to the 30th power, you're going to get a probability that occurs of basically 0. But your point is well taken, right? Like if I did have perfect competitive balance, I now have additional issues that my league's gonna have to deal with. I don't know what I don't even know if there are contingency plans for that.
Yeah.
I mean, it is a possibility technically. But yeah, you're right. If I move towards competitive balance, I might run into issues of like, well, if I have the same record, who goes, and you see that kind of in divisions, right? So you can think about the NFL has competitive balance overall. There's also competitive balance within divisions. And for that, it's more likely you see similar number of wins. And so they have contingency plans.
Yeah, like
If you dove into the rule books, maybe they do have. I don't know. Like maybe it goes to the prior season or whatever it is. But yeah, no, good point though. You would present additional challenges if you really had a perfectly competitive balance league. So when we practice, when we look at these, like none of them are going to be perfect, right? They don't want to be. Because they don't want to have to deal with these issues. They don't want it to be confusing of who's going to kind of like this. You don't want it to be confusing who's going to the playoffs and why because of this rule. Like this was the tiebreaker, and they had to go. Well, the first and second tiebreaker didn't conclude, so I had to go to a third. They don't really want that, and so yeah, you never see them push for complete competitive balance. Does that kind of what you're asking? Yeah.
I was just curious about that.
Yeah.
You had pulled it up.
Yeah. Feel free to ask that in class next time.
Okay.
I forgot mine.
Oh, okay.
I'll let you know, I sent you an email about
Okay.
that.
When I upload them, I'll go back in
Yeah,
there.
awesome. Yeah, I keep forgetting to switch it over to my bag, so.
It's all good.
That's good. So appreciate it. Bro.
Yep. Might enjoy the course.